Okay, everyone. These are the notes that I promised to give you on something called molar mass. So far, you guys have a very general introduction into what a mole is. And a mole is just a really, really, really big number, right? 6.02 times 10 to the 23rd. At this time, what you're going to be doing is taking some notes in your notebook, and then afterwards we are going to look at this particular worksheet. So have this worksheet ready because I'm going to refer and come back to it. Alright, let's get your notes started. Okay, it's also going to be important for you to get out your periodic table. We're going to be looking at some values here on the periodic table. It's really important that you have that also available. Alright, so let's begin by an introduction of molar mass. That's what we're learning about. First of all, let's start off with the definition. Molar mass is the number of grams. The number of grams of a substance that represents you're taking notes 1 mole of that substance. Okay, so molar mass is represented in the following formula, or unit, sorry. So molar mass is represented in the number of grams that it takes to represent 1 mole of the substance. So it has a unit of grams per mole. So we can give you like a couple examples, and here's the really cool part. On the periodic table, that's where we're going to find all of our masses. So if I switch over to the periodic table here, I'm going to zoom in nice and close so you can read. Okay. You guys learned way long time ago that the atomic mass of a substance is the bolded number that you see underneath the symbol of hydrogen. So the atomic mass is what we called it, or if you will, we called it the average atomic mass. Well, this number right here does represent atomic mass, but there's also something else that it represents, and this is going to be kind of new to you. Basically, here's what you guys need to know. If I had 1 mole of hydrogen atoms, okay, what would that mean? Well, that would mean that I would have technically 6.02 times 10 to the 23rd atoms of hydrogen. That's a lot of hydrogen atoms, huh? Okay. But since atoms are so tiny, what's cool is that you can take his atomic mass, which was 1.00794, that's its atomic mass, and we could say that if we had exactly this many atoms of hydrogen, we would have this many grams of hydrogen present, which is kind of cool. So what this mass would mean is that I had exactly, this would be equal to 6.02 times 10 to the 23rd atoms of hydrogen. See how I have equal signs? Alright, I hate to break it to you guys, but in this unit, so anytime, and like in chemistry in general, anytime you see equal signs, you should be wary of something. Because what this means is that you're going to have some dimensional analysis. You're going to have to convert your units. Yeah, so I know that conversions are not something that we like to talk about, but and that you guys probably dread. But anytime you do see those equal signs, you're going to probably be looking at some kind of conversion. That'll come a little bit later on. What we want to work on now is to get you guys to do something called molar mass. So I'm going to give you guys a couple examples, and then we'll look at your homework for tonight. So I want you guys to tell me what the mass of 1 mole of carbon dioxide would be. We'll just make this our very first example. So all of the rules that you guys learned for naming and formula writing, those will extend and continue in this unit. So don't think that you can just learn and forget how to name and formula write acids, molecules, and ionic compounds. All of that just continues. So first thing that we need in order to figure out the molar mass of 1 mole of carbon dioxide is we would need to get the formula of carbon dioxide. So this is a molecule. The first atom does not have a prefix. That means that there's only one. But this guy does have di, which is 2, and that's oxide, which is CO2. So I need to figure out the molar mass of carbon dioxide. So I'm going to break it down. In 1 molecule of carbon dioxide, there's going to be 1 carbon atom, right? But there's going to be 2 oxygens. What I'm going to do now is flip over to the periodic table, and we're going to get a closer look at the molar mass of carbon and the molar mass of oxygen, which really is just their atomic masses. So we're going to go to the non-metal side. Okay, I'm going to give you some rules about how to use molar mass in my classroom all the way until the end of your honors chemistry class. When you come into AP chemistry, the rules change a little bit. So we are definitely going to be concerned with significant figures. That's going to come back too. All right, but we're not going to do conversions or any math just yet, but it's coming really soon. So for now, here's the rule. When you take molar mass off of my periodic table, here's the rule. You always round your molar mass at the 10th place. At the 10th place, right here. So on carbon, that would be right here at the 0. So you always look at the next number over in the 100th place to see if you need to round up. All right, so the atomic mass of carbon off of the periodic table is 12.011. You were just told that you need to round to the 10th place, which means you're going to check the 100th place to see if you need to round up. You do not. So the molar mass of carbon would be 12.0 grams per mole. Okay. Oxygen. Find oxygen on the periodic table. His atomic mass on the periodic table is 15.9994. So let's look at this guy's 10th place right here. Do you need to round the 9 up? Sure. But that's going to increase the number 1 more over. So that's going to be 16.0 grams per mole. Now here's where we need to just take a break and kind of remind you of a couple things. These masses right here are the mass of only one of those. Okay? But you have 2 oxygens. So guys, we want the mass of CO2. CO2 contains 1 carbon, 2 oxygens. So what am I going to have to do to this guy's mass, the 16.0 grams per mole? I'm going to have to double it because there's 2 of them in the formula. And I can do that math in my head, that's fine. I'm just kind of showing you the steps here. This would be 32.0 total grams per mole. Alright, so to get the molar mass of CO2, we would take the mass of carbon, which we said was 12.0 grams per mole, and we would add to it the 2 oxygens, because there's 2 oxygens in the formula, and that would be 32.0 grams per mole. And we would add these together. Oh, and by the way, you'll see me do this occasionally, and the guy in the video did mention it. MOL is a symbol for mole, and I accidentally do this all the time because I've been doing this so long. I don't mean to confuse you. MOL is a symbol for mole. So if you see me chop off the E at the end, just know that MOL is a symbol for mole. Sorry about that. Alright, so we're going to add those 2 up, and that will give us 44.0 grams per mole. That would be the molar mass of CO2. So when you go to your worksheet, okay, here's your worksheet. The first thing that you guys have to do, there's an example for barium chloride. The first thing that you have to do is to write the correct formula. And then underneath, you're going to show me all the work for your molar mass. You see how I showed my work? I'm expecting you all to show your work. So, you know, I do need to see the 137.3 plus the 71.0. Make sure all your masses are rounded to a 10th. And guys, when you add, notice I already did it here. I could have just said 44, huh? What's the difference between 44 and 44.0? Significant figures. That's right. 44.0 has an additional sig fig. You need to make sure that even if it rounds to a perfect number, you're putting 0.0. So all your molar masses on your answers to this worksheet, sorry, over here, all your molar masses need to go to a tenth. So you may want to make like a special note somewhere on this worksheet to remind yourself that all your molar masses have to go to a tenth. All right, what we'll do is real quickly do number 1 together as your sample exercise. Okay, so here's number 1. Let's do it together. You're going to need your periodic table with the cation and anion sheet just to make sure you got this, okay? All right, so silver, find this guy on the periodic table, and I'll remind you of a few rules that we learned a while back. Okay, so silver is, let's see, here he is, he's right here, okay? He is in the D block, but he is one of the elements that is in that triangle of stability. So if you look on the back side of your periodic table, you're going to see his charge. What's his charge? It is positive, just positive 1. Okay, the next guy that you see is sulfate. It has an 8 ending. Do you remember where that comes from? It's on your list. It's polyatomic. So SO4, 2 minus. When you bring these together, the correct formula, Ag2SO4. So I would expect you guys to be doing this, showing this kind of work underneath this problem, fitting it in. All right, now comes the time for the molar mass. So let's go to the periodic table. Silver is 107.86. How would I round that? 107.9. Good job. So Ag would be 107.9 grams per mole. How many do we have in the formula? We have 2 of those. All right, so calculator time. I'll help you out. 107.9 times 2. This would be 215.8. Next would be sulfur. Let me show you on the periodic table what he looks like. Here he is. 32.06. How would you round this? You got it. 32.1. Look at the formula. How many sulfurs did I use? Only 1. So that's easy. Notice I'm lining up the decimal. That will remind me that I'm going to have to put in a 10th place on there. Alright, so let's go to oxygen now on the periodic table. Oxygen says 15.999. Oh dear. So what does that 9 in the 10th place round to? A 0. So then it's not 15 point, it's 16 point, yeah, 16.0 each. Oxygen. How many oxygens were in the formula though? Yeah, 4 of those. Alright, so 16 times 4 is 64. Don't forget that 0.0. Okay, let's add it up. 215.8 plus 32.1 plus 64. That's going to give me 311.9. And yes, you have to bring over that 10th place. This is your final answer. Please put a box around it. All right, put a box around your answer. Okay. All right, so we did that first problem right here. Now it's time to talk about this little box on the side. This little box on the side is really simple. All I want you to be able to do is to count how many of each atom you've got and the total number of atoms in the entire formula. So I'll show you an example over here. Okay. So in the formula, let me choose a different color here. In the formula, you've got silver, sulfur, and oxygen. Every capital letter represents a different element. All right, so Ag, how many Ags do you guys have? 2 atoms. So this goes in that little box. How many S atoms do you have? 1 atom. And then how many O's do you have? 4 atoms. Alright, you can do this in your head. 4, 5, 6, 7. Total of 7 atoms. Okay, and do me a huge favor, just kind of put a box around that for your total. But show your work. It's important to show your work. I'm being real stringent here about showing work because if you don't get the answer right, I want to be able to see where your mistake was. I want to know what your weakness is. It'll be easier to identify if you show your work. If you don't show your work, I'm just going to mark it wrong, and then you won't get any feedback. All right, so it's really, really, really important for you to show your work, and that way I can show you where you went wrong. All right, everyone, how about one more? Do we have time? Yes, we do. Okay, so the first thing you have to do, again, is to figure out what the formula is. So let's see, copper 2. Do you remember what that means? Yeah, that's its charge. Good job. This time it's nitrite. You got to be really careful. Some people get kind of confused between nitrate and nitrite. So be really careful. That does say nitrite. This would be NO. I can't remember. I think it's 2. Does anybody have that on them? Is it NO2? Cool, and it's just negative. All right. All right, so when we bring these together, it would be Cu, NO2. Now what do I do? Because I need 2 nitrite, sorry. Parentheses. Yeah, see how those rules don't go away? You still need to know that. Okay. All right, if you want to, over in this box, you can start filling in. Now that you've got the formula, you can start filling in. How many copper atoms do you guys have? Mm-hmm. All right, you got N and you got O. How many N's do you have? Yeah, you gotta incorporate. Yeah, you gotta. It's just like foiling. It's just like foiling. You have to foil the number on the outside in. All right, so you're gonna have 2 nitrogen atoms. This is why we do this. Yeah, and you foil this in too. Foiling means that you multiply. You multiply. Okay. How many oxygens do you have? 4. Okay, so the grand total, 4, 5, 6, 7 atoms again. So. All right, but let's go ahead and do the molar mass now, okay? All right, let's do copper. So grab the periodic table. Let's check on copper. Let's see. Here we go. Copper is 63.54. What does that round to? 63.5. Okay, nitrogen. I'm going to look him up. 14.00. So that's easy. 14.0. But how many nitrogens do you have on here? Yeah, so you need to make sure you multiply that by 2. And that would give you 28.0. And there's only one of these, so that would be 63.5. I'm showing you proper work here. Okay. Oxygen. Okay, I want to show you oxygen one more time. It's 15.99. What does that round to again? 16.0. Good job. Don't forget the .0. And there is 4 of those. Let's see. 16 times 4. That's 64.0. Okay, so there's your 3 masses. We're going to add them up now. You should get 155.5 grams per mole. Molar mass, grams per mole. The unit for molar mass is grams per mole. Did I do that right up here? Did I just say grams? Ah! Bad Crowley. Grams per mole. Sorry about that. Grams per mole. Alright, is it starting to look kind of easy? Okay, so molar mass is a concept that I will make it more tangible. In other words, make it more real world, probably next class. But I just have to make sure you get the formulas and the math right, then we can move on. Alright? Alright, happy trails, folks. That was it.